Hello everybody, I hope you're all doing well. Welcome back to another video. And in this video, we're going to be taking a look at a question from the IB Chemistry Paper 2HL from the November 2017 batch. In this question, they're asking us, cobalt forms the transition metal complex. And then they've given us this transition metal complex over here. And notice how my uh, very odd looking circle only covers the part which is in brackets and it does not cover the Br. Now you may feel that why have I discriminated against this bromine? Well, that is actually because for this entire question, you mostly need to only look at what is inside the brackets. And why do I say that? And that is because when we write down the notation of a transition metal complex, only what is inside the brackets is considered as the complex ion, which is what we deal with in the first two questions or the two sub questions. So we should only pay attention to what is inside the bracket over here. The bromine is also a part of this transition metal complex, but it is not part of the complex ion. The complex ion is only what is inside the brackets. That is something you need to remember. Otherwise, you'll have some confusion in the exam. So just remember that. Now they're asking us in the first part, state the shape of the complex ion. Well, we know in order to get the shape, we have to see how many electron domains there are. We have to see what is attached to the central metal ion. So let's take a look at that. We have cobalt in the central, CO. This is a transition metal. And as you know, that transition metal can have variable oxidation state. That means they can have different type of oxidation. They can have +2, +3, +4, +5. They are basically very flexible when it comes to their oxidation states. That's why they can hold so many different compounds to them. And this is actually these atoms or these ions that are attached, these molecules which are attached to cobalt are called ligands. Now, what is a ligand? A ligand is any substance which has the ability to act as a Lewis base. And what I mean by that is that it donates a pair of electrons, a lone pair of electrons, to a central metal atom or a central metal or central atom, which is able to take that in. And by that, cobalt acts as a Lewis acid, which is a lone electron pair acceptor, and NH3, H2O, and chlorine, just taking a look at what's inside the bracket, taking a look at what's inside the bracket, they act as a ligand because they donate a lone pair of electrons. So that's a Lewis base and a Lewis acid. I'm not going to get into that right now, but if you would like to know more about a Lewis base and acid, please visit my previous videos and I explain all of it there in detail. Anyways, so how will this look like? How can NH3 act as a ligand? Well, let's take a look at NH3. This is the structure of NH3. And as you know, nitrogen is in group 15. That means it has 5 valence electrons, and you can see that it is only using 3 in bonding. So it has another pair over here. Now this is this lone pair. So NH3 can use this lone pair. It donates this lone pair to cobalt and it forms a bond. And as you know that in a bond, there are 2 electrons, and usually the 1 electron comes from the first participating atom and the second electron comes from the second participating atom or molecule. But in this case, in the ligand's case, the 2 electrons that are in the bond are both contributed by the ligand, in which case, in this case, it's NH3. And this type of bond is called a coordinate covalent bond. So this coordinate covalent bond is usually signified with an arrow, but we don't really do that. It is okay to just leave it like that. Now, I'm just going to draw out the complex metal because it will make it easier for us to really see what's going on. So let's draw it. We can see that there are 4 NH3s. And we have 1 H2O. And we have 1 chlorine. And as you can see, how many molecules are attached, or atoms or ions are attached to cobalt? There are 1, 2, 3, 4, 5, 6. And since there are 6, and we don't really see any lone pairs on cobalt, we can consider this as octahedral. This is the shape of this as octahedral. Oops. Forgive me for my handwriting. So the shape of this is octahedral, and it is, in such cases it is very difficult to really know what the exact shape is, because this is not exactly going to be an octahedral. It depends on a lot of things, because you have molecules attached to cobalt, and there may be some, what do you call, repulsion between these molecules, and that may not result in a shape that is exactly octahedral. But in IV chemistry at this level, they don't need you to get into the details. If you see six different molecules, or six molecules attached, or six electron domains on cobalt, you have 1, 2, 3, 1, 2, 3, 4, 5, 6. If you see that, and you know that 6 means octahedral, then that is all you need to put down. You don't have to get into the details and the any specifics. And that's why you can see it's also only worth 1 mark. Now, moving on to the next part. The next part shows us deduce the charge on the complex ion and the oxidation state of cobalt. Now they're asking us to only deduce a charge on the complex ion, and as I told you earlier, the complex ion is only considered what is in the brackets. That is only what the complex ion is. The bromine is also attached to cobalt, but we do not consider that as part of the complex ion. It is part of the transition metal complex, but it is not considered as a part of the complex ion. So only what's in the brackets is considered as a part of the complex ion. So let me just write this over here again. Oops. Now, what is the charge on this complex ion? So, well, let's see. In order to determine the charge on this complex ion, we also have to consider bromine on the outside. Even though it's not really a part of this, these guys are the cool kids, even though it's not a part of that, you still have to consider it, because the oxidation state of cobalt and the oxidation state of these other, or the charge on these other molecules and atoms or ions, contributes to the overall charge on the complex ion. So chlorine has an oxidation state of -1. We know that. Does NH3 or H2O have any charges on them? Well, sorry, I meant chlorine has a charge of -1. Does NH3 or H2O have a charge on them? No. NH3 and H2O are both neutral molecules. We know that they're neutral. They don't have a charge on them. We never write something like H2O minus. No, it's just H2O. It's a neutral molecule. Whereas for chlorine, we write Cl minus. And the same case goes for bromine. For bromine, since it's in group 17, we also write Br minus. So the charge on this is also -1. That would mean that the overall charge on cobalt would be +2, or the oxidation state of cobalt would be +2. And this would mean that this whole transition metal complex is neutral. However, they are only asking us for the charge on the complex ion excluding the bromine, even though this charge on bromine affects the oxidation state of cobalt, we do not consider it as a part of the complex ion. So really, the charge on this complex ion, just forget about bromine, excluding bromine, is going to be +1, because cobalt has an oxidation state or charge of +2, and chlorine has of -1. So 2 minus 1 is equal to 1. Thus, the overall charge on the complex ion is going to be 1 plus. Sorry, that's how we write it. My apologies. Hopefully that is clear. I know it's a bit tricky to understand. Even I'm finding it a bit difficult to explain it, but hopefully you get an idea of what I'm talking about. And like I said, NH3 and H2O have no charges. They're neutral molecules. So That is that. Now they're asking us, what is the oxidation state of cobalt? Well, we just saw it. The oxidation state of cobalt is +2. And I want to point out a very significant difference over here. When you write an oxidation state, like I have written over here for chlorine and for bromine, the oxidation state is written with first the sign, so minus, and then the number. Whereas the charge is written as first the number, first the number, and then the sign. This is a very, very important difference. If you write this will be wrong. That is not correct. It should be 1 plus. And the oxidation state is written like this, with first the sign and then the number, and the charge is written as first the number and then the sign. I know these are very petty differences, but in the long run, they have very big implications, especially in the exam. So just make sure that you remember this when you're writing your papers. The charge is written as first the number and then the sign, and the oxidation state is written as first the sign and then the number. Anyways, I hope that my video has helped clear this concept of determining the charges or the oxidation state of metals and the complex ions and the shapes as well. Hopefully, you'll be able to solve such questions with ease if they do appear in the exam. Thank you so much for watching this video. If you have any questions regarding this concept or any other concept, please feel free to reach out to me on my social media, send me an email, or put it down in the comments below, and I'll be more than happy to help you. Thank you for watching. Take care, and I'll see you in another video with another question.